Assalamu alaikum wa rahmatullahi wa barakatuh. Dear student of third prep, we are going to illustrate today. We have unit 1 chemical reactions. We have the lesson that we want to know everything about it. We have lesson 2 speed of chemical reactions. Okay, we have different reactions and study before that we have different kinds of chemical reactions, but we wanted to know how we can affect the speed of the chemical reaction. Let's start with our constituent of this lesson. We will start with the definition of chemical reactions that we have taken in the last lesson, that it's breaking up of bond in the molecules of reactant. If we want to make the reaction, that we will start with the molecules of reactant, product, and the conditions of reaction. So we called them, we can make a reaction. We have the bond inside the reactant molecule that we will breaking up it, and we will form a new bond in the molecules of product. So chemical reaction, breaking up of bond in the molecules of reactant and formation of new bonds in the product molecules from the reaction. Okay, so what is the meaning of speed of chemical reaction? Speed of chemical reaction, we will discuss at first kinds of different reactions depending on the time that it taken. We have the very fast reactions like the fires or the fireworks that we make in the feast. Okay, we have another one, relatively slow reactions like what, like rust of iron that make oxidation that take a long time immediately. And the third one here, very slow reaction that depend on the presence of temperature, like adding oil to sodium hydroxide to form soup. And the last one here, two slow reactions like formation of petroleum oil under the earth's crust. It take a long years or 100 years, and it depends on the presence of high pressure and temperature by the affecting on the dead bodies and the plant remains under the earth's crust for a long years. Okay, these are the kinds that has has all have different what different measurement or different times for happen. Okay, let's discuss. We have the concept of the speed of the chemical reaction. We have in the chemistry that we can express the amount of reactant and product per unit time. So we can use the presence of reactant or the appearance of product and disappearance of reactant within the unit time that will cause or that making the reaction happen. So in here we have the black dots that mean the black molecules here that are the reactant, and the red one are the product. So by increasing the product here within time and by decreasing the reactant within time, so the reaction takes place in the molecules that taking with a unit time. Okay, we have also another example. We have reactant X and reactant Y. Okay, by passing time, reactant X disappear and reactant and product Y will appear here by the time, and the reactant X disappear. So if we make a graph for illustrating this one, we will have the purple line that indicate the number of molecules of reactant that decreases by time to till it stops, and increasing the rate of reaction of product with the green color by the time. So the concentration of reactant at the beginning of reaction will be 100%, and concentration of product at the beginning of reaction will be 0. By the time the concentration of reactant at the end of reaction will be 0, and the concentration of product at the end of reaction will be 100. So we can measure this one to indicate what? To indicate the speed of chemical reaction. Okay, so from the previous activity we have the at the beginning of reaction we have molecule A and molecule B. At the beginning, reactant X, that largest in amount, and the concentration decreases by time. So at the end of reaction, the concentration of reactant will be the smallest or equal 0. Okay, also the molecule Y or molecule B. Here we have the concentration of product Y will be the smallest at the beginning of reaction. By time concentration will increases, and at the end of reaction the concentration of the products become the largest with 100%. From the previous explanation we have to discover that the meaning or the concept of speed of chemical reaction will be change in concentration of reactant and the resultant at a unit time. We have an application for the speed of chemical reaction. We have the speed of decomposition of nitrogen pentaoxide in 2O5, that it will give nitrogen dioxide and oxygen. So we have the reaction here 2N2O5 that it will decompose into 4NO2 nitrogen dioxide plus O2 gas. So the equation will be balanced here, and we will have the graph illustrate the relation between the reactant and the product. We have the first one here. Starting from the reaction, we have what? We have the substance nitrogen pentaoxide that decompose by the time or break up, that giving at the end of reaction 0. So the concentration of reactant at the beginning here 100% and at the end will be 0. And we have also two products, we have nitrogen dioxide and oxygen. At the starting we have the concentration of the react of product will be NO2, that will be product with the side product will be oxygen. So the main product with the high amount for NO2 will be the nitrogen dioxide, and the lesser amount will be oxygen here, this line. Okay, let's continue. We have also from the previous graph we conclude that as the concentration here of reactant starting 100 here in 205, and the concentration of reactant decreases within time, at the end will be 0. Starting the product NO2 and O2 0, by time increases, and at the end of time the product will be the largest or high percentage. So at the end of reaction concentration of both what reactant and product is constant by passing time. So if we measure the concentration of each of them in any point in the middle or by passing time, we will find that concentration of both reactant and product all have the same amount or are constant. One of them increase and the other will decreases in the what in the previous direction. Okay, also we have another example for it. We have exercise that explain the graph that we wanted to know. We have exercise that it is in your book, in your student book. We have this exercise. We have 2x that giving by decomposition or breaking up giving 2y plus z. We have here number 1 concentration decreases, okay, 2x here. Okay, we wanted to know what is the question. Replace the numbers shown on the figure with the suitable substances x, y and z. Okay, give reason for your answer. Okay, we have the answer here that x will be number 1 because it represents the reactant substance where its concentration at the beginning equal 100 and at the ending equal 0. Also we have 2 will be Z and 3 will be Y. Why? Because the it represent or they represent the resultant where their concentration at the beginning 0, at the end will be 100. Also we have the number of moles of substance or the amount of substance Y greater than the amount of substance Z. In the equation we have 2Y, but we have what? 1 Z. So the 3 will be Y and 2 will be what? Will be Z. Okay, well, let's continue. We have the measuring the speed of chemical reaction. What do we do to mention the speed of chemical reaction practically? Practically by disappearance of reactant, or we didn't see it completely, and or appearance of product. So the appearance of product or resultant means that the speed of reaction happen or the reaction occurs. So by the disappearance or appearance of product or resultant, so we have the speed of reaction here. We have application, the rate of reaction of sodium hydroxide solution with copper sulfate solution. We have sodium hydroxide and it is colorless solution. Another one we have copper sulfate, and you know its color, as we said, it's the color of the sky or sea. We have the blue color, we have copper sulfate blue in color, and we make the reaction between them. What is the product? Will be sodium sulfate Na2SO4 with a colorless solution, but we have the percepted here that will be by double substitution. We will have copper hydroxide CuOH by 2. It is the tube that containing a blue color percepted that indicate that the reaction happens. So the appearance of blue percepted of copper hydroxide indicate that a reaction occurs, or disappearance of the color of copper sulfate solution indicate that the reaction occurs. Okay, so we have the speed on the previous practically by the disappearance of the rate of blue color of copper sulfate solution as a reactant, or the formation rate of the blue color percepted of copper hydroxide as a resultant. We said what are the factors? We need to know what are the factors that affecting the speed of chemical reaction. At first we will know the speed of chemical reaction affected by three factors. We have nature of reactant, number 2 concentration of reactant, 3 temperature of reaction and catalyst. Okay, we have all these are the factors affecting the speed of reaction. Let's discuss the first one of them. We have the nature of reactants. We have nature depend on the two factors consist of it. We have the kinds of bonds in reactant and also the surface area of reactants exposed to reaction. Okay, we have 2 points that we will discussing. The first one here, that the kind of bonding in reactant. We have the kind of bond in reactant. We have two kinds of bond that we discussed before. We have the ionic and covalent. Do you think which one will be the fast and will be the slow? We have the first one, ionic compound. If we have 2 cups of water and we have 1 spoon of 1/2 salt and the other is sugar. Okay, we will dissolving each spoon in the same amount of water. What will be dissolving faster? We have the first, that dissolving faster will be what? Will be the salt. Why? As it is ionic compound, as it dissociate or break down into ions and dissolves completely inside the molecules of water. So it break the bond between the molecules of water, as the molecules covalent bond inside the water, it break it and make the reaction between the ions. So the reaction will be so fast. Reaction between ions will be so fast. But if we have the covalent compound, molecules of covalent, we have the molecule of sugar and it's a huge size. Also we have molecule of water, so the reactions will be with two with a large amount and very active one, so the reaction will be take a long time, and the reaction will be between molecules and will be slow. Okay, so we have give reason here that reactant of or the reactions of ionic compounds are fast, but the reaction of covalent compounds are slow. We have the first one here. Reaction of ionic compounds are fast as they takes place the reaction takes place between the ions, where they break up or dissociate completely into ions on dissolving in water. But we have the most of reactions of covalent compounds are slow. Why? Because they takes place between or they take place between molecules where they are difficult to ionize on dissolving what on in water, so the reaction take a long time and it will be slow. As here we have give reason, the reaction between sodium chloride solution and silver nitrate solution is from fast reactions. If we said any one will be fast, it will be ionic. Any one will be slow, will be what? Will be covalent. So why it is ionic will be fast? Because it takes place between ions that results from dissociating of each of them in water. And we have here, we must write the equation. If we said any give reason, we have a reaction, so we must write what? The equation. We have sodium chloride in NaCl plus AgNO3 that produce sodium nitrate NaNO3 plus silver chloride white precipitate AgCl. Okay, this is very important question. Let's go into another question. We have the surface area of reactant exposed to reaction. This is the other factor of the reactant kind of reactant. We have the kind of reactant and the other one surface area of reactant exposed to reaction. Okay, we have surface area. We have two substances here, the one A and B. One A with here with a small size and B with a big size. We have a molecule A that surrounds a molecule or a substance with molecules B. Okay, the purple one here or pink one, that molecules of substance A reacts with molecule of B with the outer surface only and no reaction inside the inner parts here, inside the bulk of what? Of the substance B. So the reaction will be slow. Okay, suppose we have another substance with another shape. We have reactant substance B, like a powder or fillings or turning. We have this shape. Okay, it will be decomposed into smaller what? Smaller bits. We have the molecules of A distributed in between the molecules of B. Okay, we have the molecules of A reacts with the molecules of B with inside the bulk without any bulks here, and all outer surface area exposed to the substance A. So the reaction will be fast. Okay, why here the reaction will be slow? As the surface area exposed to reaction is small, and also here will be fast because the surface area exposed to the reaction is large. So from the previous explanation we have to conclude that as surface area exposed to reaction increase, we have the factor as surface area of reactant exposed to reaction increase, so the speed of reaction increase. It is a direct relation. By increasing surface area exposed to reaction means it will be small into parts, so the speed of chemical reaction will be increases. Okay, we have the points of activity, that effect of surface area on the speed of chemical reaction. If we have iron filling and one piece of iron, we have the two flasks here and two strings and two, two equal amount of what? Of diluted hydrochloric acid, and we put each one till the reaction happen. Okay, so after time we will see that the rate of reaction of hydrochloric acid with iron filling will be faster in the flask A. So the reaction, we conclude that the reaction get faster in case of small pieces of iron. So the speed of reaction affected by increases by increasing surface area of reactant exposed to what? Exposed to reaction. It is a direct relation, and we have this factor affecting what? Affecting the speed of chemical reaction. So we have the reaction here Fe plus 2HCl that giving diluted will give B, will produce FeCl2 plus H2 evolving. The reaction here we said that give reason if we have the speed of chemical reaction increases by increasing surface area of reactant exposed to reaction. Why? Because or due to the increase in the number of molecules of reactant exposed to the reaction. Another give reason we have using nickel filling in hydrating oil instead of pieces of nickel. Why? As because the speed of chemical reaction increases also by increasing the surface area exposed to reaction. Okay, we have the other factor or number two, concentration of reactant. What do we mean by concentration of reactant? We have the concentration means that the probability of presence of large amount of molecules means the large amounts of molecules mean a crowded places, so it will make a substance make collision, or the probability of collisions between persons in crowded streets bigger than that in a quiet street. So we have here the low concentration means that slow reaction, and the high concentration means that is a fast reaction. So when the concentration or the number of molecules of reactant increases, the number of probable collisions between the molecules increases, and thus the speed of reaction will be increases. We have a collision theory that explains this. We have number of atoms, ions, and molecules to form the product. We have collide between them, making a kinetic energy. If this kinetic energy enough to make the reaction, so they will collide with each other and produce what? Produce energy that make the reaction. But if we have n, if we see this one, we see the difference between them. We see the difference between them. Effective collision here will make a decomposition of oxygen and hydrogen forming water, but here we have ineffective collision of molecules and no reaction will occur, so the reactant produced as it is. We have here a collision theory. If we have enough molecules or enough kinetic energy, the substance will take the product will be happen or product will not happen. It means that if we say we have collisions occur, that kinetic energy enough to produce what? Produce the product. This is the meaning of collision theory here that we have. So if we have here the minimum energy that colliding particles must have in order to react is called activation energy. We have here the reactant and we have activation energy to make the reaction. We have reactant here and the product here. So we between them we have the activation barrier must be crossed before reactant are converted to product. Okay, so we have here the activation or activated complex and it will produce the product. Okay, so it will be the change will be here the activation energy. This is the energy released by the reaction. So the reaction progress means that we have enough amount to make that the reaction happen. Okay, collision theory also explain why some reactions are extremely slow at room temperature. Okay, at room temperature, collision of some molecules are not energetic enough to break down the molecules or the bond between the molecules. Thus, the reaction rate between these molecules at room temperature will be what? Will be 0. So the molecules must collide with enough energy in order to react, as minimum amount of energy needed is called the activation energy. If we have enough amount or small amount to make the reaction, we called it activation energy. I want to make the reaction happen, so in room temperature it will not happen, so I will give it some activation energy to make the reaction. Here we have the activities that explain the effect of reactant concentration on the speed of chemical reaction. We have two flasks, two syringes, and also we have diluting HCl and concentrated HCl with the equal amount of magnesium ribbons, two equal pieces of magnesium ribbons. We have here magnesium reacts with hydrochloric acid to give magnesium chloride and hydrogen gas evolving. So if we put the piece of magnesium ribbon in each class and add small amount of diluted HCl in flask A and another amount of concentrated HCl in the flask of 2 by pipette, comparing the number of evolved bubbles here in case of concentration and diluted HCl, observation will be that the number of evolved bubbles in case of concentration HCl is greater than dial HCl. So here we have the concentrations, means that the molecules in concentration acid will be greater than the diluted acid. That leads to probable collision between the reactant molecule that increase the speed of chemical reaction. So the speed of chemical reaction increases by increasing what? The concentration of reactant. Okay, so we have a direct relation here between what? Between the concentration of reactant and the speed of reaction. By increasing the speed of reaction, by increasing concentration of reactant, the speed of reaction will increases. We have give reason for this point. We have speed of chemical reaction increases by increasing concentration of reactant. Why? Because by increasing the number of reactant molecules, the number of probable collisions between them increases. Okay, we have here steel screws. We have the steel wool, and it will make burning to it. And another one inside a flask containing oxygen only. So composition of steel screwers used for cleaning aluminium pots in jar filled with oxygen faster than in composition in atmospheric air. So the reaction here will be faster and the iron piece will be completely burning happen quickly due to increasing the speed of chemical reaction by increasing what? The concentration of oxygen gas. We have another point. We have temperature of the reaction. If we have water here and molecules increasing the temperature of reactant, the speed of reactant molecules will increases. So also the number of probable collision between them increases and the speed of reaction will increases. So we have give reason also here. The speed of chemical reaction increases by raising the temperature. Why? As we have, due to increase the number of collisions between the reactant molecules. So if we have the fridge is used to preserve food. Why? Give reason. Because low temperature in fridge slows down the speed of chemical reaction done by bacteria, which cause the rot of food. Also, we have, if you want to cook a food faster, like making egg, you have to increase its temperature. Why? Because the speed of reaction of cooking food increases by raising temperature. So this is the third factor that we have. Let's go to the other point. We have the effect of temperature on the speed of reaction. Also, we have cold water and hot water. We have a piece of effervescence tablet. We have piece in hot water and the other one in cold water. Which one will be dissolving faster? We have the observation in water, in hot water. Effervescence will happen, what will happen faster than in cold water? Explanation that we have that the speed of reaction in hot water is faster as the rate of molecules collision is greater. So the collision here, or the our conclusion that we have the speed of chemical reaction increases by. We have another exercise that we have we have a pieces of calcium and calcium powder. We have a different temperature and we want to make a difference between them. We have in each of them which reaction will be faster. We have here 20 and 40, 20 and 40. We have pieces of calcium and piece and calcium powder. Okay, well, we have the answer. Figure 4 here will be the faster one as it has high temperature and also what powder or surface area exposed to reaction increase. So the figure 4, because the molecules or the rate of reaction increases by increasing surface area and temperature, we collect the two previous factors. We have temperature and surface area exposed to the reaction. We have the last one that we have, catalyst. Okay, what do we mean by catalyst? Okay, that we have very fast and another very slow. If we have the very slow reactions that we making to increase the very slow, and maybe we want to decrease the very fast one, it's necessary to add a substance to each of them but not affect the kind of substance. So we called it what? Catalyst. What do we mean by the word catalyst? It's a chemical substance which also make a reaction but changes the rate of reaction without changing or being used up, or we haven't affecting the reaction. So the chemical reaction in which catalysts are used we called catalytic reaction. And we have two types of catalytic reaction. We have positive catalytic reaction and the negative catalytic reaction. If they are positive, they are chemical which increases, catalyst increases their speed, and we have give reason. And also we have negative catalytic reaction, that negative catalytic reaction decreases the speed of reaction. Give reason, most catalysts speed up the reaction, or they are okay. Some reactant don't proceed at reasonable rate, but we have to added the catalyst. So the catalyst substance that speed up the reaction, it recovered or unchanged at the end of reaction. So it will be provide by enough amount here. We have, this is the activation energy. We have the reactant and the product, the activation to make the product here. If we adding the catalyst, so the activation energy that taken here will be what decreases with this amount with adding the catalyst. Overall, the effect of catalyst is lowering the activation energy of the reaction. Overall, it lowering the activation energy, so it will decreases the time that we make the reaction. And we have here common properties of catalyst here that we have to make the reaction. The first one, change the speed of reaction but don't affect either at the beginning or stopping. Also we have, they are used in few amount which are enough to complete the reaction. Also they are bonded to reactant during the reaction but get separated from the reaction quickly and forming the resultant at the end of reaction. We have also number 4, they decreases the energy needed for the reaction. Also the last one here, that we have no chemical change or decrease in mass occur to the catalyst after the end of reaction. Okay, we have the effect of catalyst on the speed of chemical reaction. We have glass beaker and the activity illustrating it. We have that we have taken before in 6 primary. We have the hydrogen peroxide decomposed in the presence of manganese dioxide as a catalyst. Okay, it gives oxygen and water. So we have here the reaction increasing the bubbles by the using manganese dioxide. So the speed of chemical reaction increases by adding catalyst. And also we have another substance may be similar to catalyst but as a biological substance inside our body. We called it enzymes. Enzymes inside the human body contains certain types of chemical substance which acts as a catalyst, and we use them enzymes. Enzymes are chemical substance produced by the body of living organism as a catalyst that increases the speed of chemical reaction. So the biological reaction occurs in the presence of enzymes more rapid than without it. So it will take a long time without the enzymes. Each enzyme has a specific function. Molecule of one enzyme can do its own function but can't do the other of one. So without enzymes, man can never breathe, move, or even digest food. We have the effect of enzymes on the speed of reaction. We have also another one, but the biological, we have the oxidase enzyme. Oxidase enzyme like manganese dioxide. Oxidase enzyme present in sweet potato, it acts as a catalyst that making the reaction here. So it will making decomposition for hydrogen peroxide here to give what water and oxygen. So the speed of chemical reaction increases by adding an enzyme. We have here oxidase enzyme that present in sweet potato. Okay, we will summarize our lesson today. Speed of chemical reaction, that we have the factors affecting the speed of reaction and the meaning. We have the speed of chemical reaction means the change in concentration of reactant and the resultant in a unit time. At the beginning of any chemical reaction, concentration of reactant will be 100, while at the end will be 0. At the end of reaction, concentration of reactant 0, while concentration of product 0. We have the factors affecting the speed of chemical reactions are nature of reactant. Ionic bond are fast reacting compound, while covalent compounds are slow reacting compound. As the surface area of reactant exposed to reaction increases, the speed of chemical reaction will be fast. The second one, concentration of reactant. Okay, we have the concentration of reactant increases. As increases, the speed of chemical reaction increases. Also, we have the temperature. The speed of chemical reaction increases by increasing temperature of reactant, and also catalyst. It's a chemical substance that we change the rate of reaction without being used up. And there are two types of catalytic. We have the positive catalyst and negative catalyst, and we call them positive catalytic reaction, that they are chemical reactions in which catalyst increases the speed of reaction, and also negative catalytic reactions, they are chemical reactions in which catalyst decreases the speed of chemical reaction. So the purpose of catalyst here, that it changes the speed of chemical reaction but don't affect either at the beginning or stopping at the end. They are used in a few amount in which are often enough to complete the reaction. They are bonded to reactant and even separated from the product at the end of reaction. Also, it decreases the energy needed for the reaction. We called it activation energy. No chemical change or decrease in mass occurs to the catalyst at the end of reaction. Okay, we have enzymes. What the meaning of enzymes? They are chemical substance produced by the body of living organisms, and also they are catalysts that increase the speed of chemical reaction. Okay, that's the end of our lesson today. I hope you enjoy all parts that we discuss that in our lesson speed of chemical reaction. I think it's a very interesting lesson. Hope you enjoy. Okay, thank you, good luck, and goodbye.